Welcome to the Deep Dive. We're your fast track to understanding the information that really matters. Our mission today, to cut through all the noise, and get straight to the core of some, honestly, pretty surprising twists and big breakthroughs happening in AI right now. We're talking major industry deals reshaping the landscape, cutting-edge models pushing the limits in coding, even speeding up basic science. So we'll be working through a stack of info today, mostly drawing from the top AI news insights that you, our listeners, flagged for us. Prepare for some real eye-openers, stuff that goes way beyond just the headlines.
That's exactly right. And this isn't just about, skimming headlines. It's about really digging into the underlying forces, the sheer speed of these tech advances. We'll kick off by looking at how some big tech players are making moves for talent and tech in ways you might not expect. Then we'll dive into some really fascinating new AI models, their practical uses, and how they're setting, well, new benchmarks.
Okay, let's unpack this then. First big story. It's got a genuinely surprising twist in AI acquisitions. You know Windsurf, that viral AI coding startup.
Oh, yeah, everyone was talking about them.
Well, their massive $3 billion deal with OpenAI, it just fell apart pretty suddenly.
Right. That was surprising in itself, but that's just the start, really. The real twist, the thing that caught everyone off guard, was Google DeepMind stepping in. They've hired Windsurf CEO Varun Mohan, the co-founder Douglas Chen, and some other key researchers from the startup.
Whoa, okay, but not buying the company.
Exactly. That's the critical part. This isn't an acquisition of Windsurf itself. Google's not taking a stake, no control. Instead, they're paying a huge sum, $2.4 billion, just to license Windsurf's tech, not exclusively, mind you, and bring that top talent over to Google.
Huh. That's a fascinating move. We've seen similar things before, haven't we? This kind of reverse acqui-hire. But what's the real game here compared to just buying them outright? Does it really sidestep regulatory issues or just kick the can down the road?
Well, it seems to be a strategic masterstroke, honestly.
Yeah.
A new playbook, maybe. You're right. Google did something similar to bring back Noam Shazir from Character AI.
Right.
And Microsoft had that move with Mustafa Suleyman.
Right.
The main advantage seems to be exactly what you hinted at. These deals let companies grab key talent and tech, boosting their AI position significantly. But without all the intense regulatory heat a full merger would likely attract. Like a Google spokesperson said, they're excited to welcome some top AI coding talent to advance our work in agentic coding. It's a nimble way to just scoop up the expertise.
Okay, so what about Windsurf then? The actual company. They're still around.
Yeah, they're still operating.
Yeah.
Their head of business, Jeff Wang, he stepped in as interim CEO. Most of their team, about 250 people, are apparently staying put. They'll keep offering their AI coding tools to enterprise clients.
But, historically, when startups lose their key leaders like this, what happens? What are the big challenges? Is there really a path for Windsurf to recover its momentum here?
That is the million-dollar question, isn't it? Or maybe the billion-dollar one in this case.
Mm-hmm.
The sources do point out that other startups where leaders got hired away, like Scale AI or Inflection, they often struggled. Windsurf was one of the hottest AI coding startups. They apparently hit around $100 million in annual recurring revenue recently.
Wow.
So yeah, this definitely leaves them in a much shakier spot, even as Google gets this major boost in AI coding, which is a super hot area right now. Their challenge, proving they can still innovate and grow without that core leadership team, it's tough.
Right. Okay, shifting gears a bit. Let's move from the industry chess game to the actual tech. Some cutting-edge AI models making waves, specifically in coding. Mistral AI, working with All Hands AI, just put out Devstral Medium and an upgrade to Devstral Small.
Yes, and what's really interesting here is how these Devstral models are built for what's called agentic coding.
Yeah.
Basically, getting the AI to act more like an independent software engineer, understanding code, writing it, even debugging it on its own.
Oh.
Devstral Small 1.1, that one's open source, Apache 2.0 license.
Yeah.
And it's setting a new state-of-the-art for open models. It hit a 53.6% score on SW Bench Verified.
On for listeners, that SW Bench. That's a tough benchmark.
It really is.
Yeah.
It tests the AI's ability to fix actual software bugs from public GitHub issues, so real-world stuff.
Yeah.
And it's versatile, too, supports Mistral function calling, XML formats, making it adaptable for different coding setups, different agent frameworks.
And Devstral Medium, the bigger one, pushes that performance even higher. What does that mean practically for, say, developers or businesses using it?
Absolutely. Devstral Medium, which you get via their API, hits an even higher score, 61.6% on SW Bench Verified. That's really strong. But what's maybe even more impressive is its cost performance. It apparently beats models like Gemini 2.5 Pro and even GPT 4.1 but at a fraction of the price.
Oh, interesting.
Yeah, so it means powerful, high-quality AI for coding becomes much more accessible financially for businesses, for individual devs. Plus, you can deploy it on-premise if you need extra data privacy. It really feels like a new point on that cost versus performance curve, making advanced AI coding tools just more practical for more people.
That focus on efficiency and accessibility, that leads us nicely into the next thing. Models from Reka, specifically Reka Flash 3.1 and Reka Quant, sounds like they're also making powerful AI more practical. How are they doing it?
So Reka Flash 3.1 is their improved multimodal base model.
Right.
It's particularly strong in coding and apparently really good for fine-tuning on those agentic tasks we mentioned. They're reporting big gains from their reinforcement learning work, like a 10-point jump on live code bench.
Okay.
But what really stands out, I think, is their Reka Quant library. This lets you do something called quantization. Basically, it shrinks the model's memory footprint way down, but crucially without a huge hit to performance.
Right, quantization, and the practical impact of that, making it smaller without losing much quality. How much does that actually broaden where you can use these models?
Oh, it's potentially game-changing.
Yeah.
For example, they managed to quantize Reka Flash 3.1 down to just 3.5 bits per parameter.
Tiny.
Yeah, super small. And they claim only a tiny 1.6% average drop in performance, near lossless, basically.
Right.
And that's huge for deploying powerful AI where resources are tight think edge devices, phones, embedded systems, or just cutting down cloud serving costs dramatically. This kind of near lossless compression means these advanced models, the ones powering Reka's multimodal stuff like Reka Research and Vision, they can potentially run almost anywhere while keeping their smarts, their reasoning, their coding skills. It really helps democratize access.
Okay, so we've covered big industry shifts, talent grabs, these really impressive strides in AI for coding and making it more efficient. But where does this leave fundamental scientific discovery? Let's talk about BioEmu. This feels like where AI steps beyond just optimizing code.
Yes, BioEmu. This is a new generative AI model just published in Science. And it's helping researchers explore how proteins move and change shape protein dynamics at speeds that were, frankly, unimaginable before. See, older models might predict just one static frozen structure of protein.
Like AlphaFold, sort of.
Exactly, like AlphaFold gave us the static picture. But BioEmu models the whole range of shapes a protein can take on, its conformational ensemble. And this is critical because a protein's function often depends on how it moves and shifts, not just one single shape. So BioEmu isn't just faster, it's like a computational microscope showing us the dynamic dance of proteins. It could open up completely new ways to find drugs, to understand biology, things that were just too slow or impossible before.
So instead of just a photo, it's like an incredibly fast movie generator, showing all the ways a protein can potentially behave.
That's a great way to put it. It's described as a high-speed emulator of protein motion. It can generate thousands of these different protein shapes, these conformational states, in just 1 hour on a single GPU. Compare that to traditional molecular dynamics simulations.
Which can take ages, right? Weeks, months.
Exactly. Much, much longer. BioEmu learns from tons of those simulations, plus AlphaFold data, plus experimental results. And it generates diverse, realistic shapes that reflect how proteins likely behave naturally specifically from their equilibrium distribution, meaning the most stable, probable shapes they adopt.
Okay, so even though it doesn't simulate the process of changing over time like the old methods, or react to changing conditions like temperature, pH, it still sounds incredibly powerful for certain jobs. Like, what could it do for drug design specifically?
Transformational, potentially. While it gives you snapshots from that equilibrium, it's perfect for high-throughput stuff where you need speed and scale. Think about drug design. Rapidly sampling all these possible shapes might reveal hidden pockets on a protein, places a drug could bind that you'd only see when the protein is moving. Or it could help design enzymes that are more stable or more active.
Yeah.
BioEmu really feels like the next step beyond just static structures like AlphaFold. It's moving towards understanding how proteins actually work dynamically in biological systems.
Right.
It compresses maybe years of simulation time into hours.
Okay, incredible stuff. So let's try and wrap this up, recapping the key highlights from this deep dive. We started with that really surprising Windsurf Google OpenAI situation. It shows how talent acquisition, how deal-making in AI is getting reshaped in these complex, almost sneaky ways sometimes. It reveals this new strategic playbook being written as we speak, and it leaves big questions about what happens to startups like Windsurf in that scenario.
Right. And we tied that directly to the innovations in AI itself, the rise of these specialized coding models like Mistral's Devstral offering amazing performance, and Rika Flash 2, and crucially, those efficiency breakthroughs like Rika Quant, making powerful AI much more accessible, more deployable, literally changing where AI can even be used.
Then we jump to that exciting edge of science with BioEmu, emphasizing how AI isn't just optimizing software, it's speeding up fundamental understanding in fields like biology, potentially unlocking whole new areas of scientific progress.
Yeah, and if you connect all these dots,
Yeah.
these seemingly separate news items, they all point to this incredibly rapid, broad evolution in AI. It's not just about what AI can do, its capabilities, but it's fundamentally changing how it's developed, how it's distributed, and how it's applied across such different areas, from business software all the way to, the basic science of life.
So what does this all mean for you, the listener, trying to keep up with this field moving at lightning speed?
Well, it highlights just that, the incredible pace of innovation and how AI's impact is becoming incredibly diverse, touching pretty much every sector you can think of.
Which brings us to maybe a final thought for you to chew on. As these AI models get more specialized, more efficient, and as the industry adopts these, let's say, novel strategies for getting talent and technology, how might these shifts fundamentally change how we develop AI, how we interact with it, maybe even how we think about AI in the years ahead? Something to consider.